In this video, let us understand 5 dimensionless numbers. First one would be Reynolds number. It compares inertia force and viscous force. So inertia force is nothing but the tendency of a moving fluid to keep moving. And coming on to viscous force, it is the fluid's internal friction that resists motion. It is like resistance. And it is used for predicting whether the flow is going to be laminar or turbulent. And by laminar flow, I mean smooth flow in parallel layers with little bit or almost no mixing. And turbulent means chaotic or continuous mixing. And now coming on to Prandtl number, it is something that compares momentum diffusion and heat diffusion. Momentum diffusion means how quickly a fluid transfers its motion between layers due to viscosity. And by heat diffusion, I mean how quickly heat spreads through the fluid due to temperature differences. Now, Prandtl number is used for heat transfer in fluids. And coming on to the next number, it is Nusselt number. Nusselt number is nothing but it compares convective heat transfer and conductive heat transfer, which is like convection versus conduction. So, we all know that convection is heat transfer caused by the movement of a fluid. It is caused because of the movement of a fluid. And conduction is a type of heat transfer which is directly through molecular contact without any fluid movement. It is used, the Nusselt number is used in heat exchangers, cooling, and heating systems. Now, coming on to Grashof number, it is something that compares buoyancy force and viscous force. So, buoyancy force is nothing but upward force created when warmer and lighter fluid rises and cooler, denser fluids sink. So, viscous force is nothing but internal friction or resistance. Now, coming on to the use of Grashof number, it is used for natural convection analysis. Natural convection analysis is nothing but natural convection means fluid motion driven only by temperature differences, and it has nothing to do with pump or fan. Now, coming on to the next number, it is Biot number. It is the comparison of internal conduction resistance and surface convection resistance. Internal conduction resistance is nothing but resistance to heat flow within a solid, and surface convection resistance is a resistance to heat transfer between the solid surface and the surrounding fluid. Now, Biot number is used for determining whether the lumped capacitance method is valid or not. By lumped capacitance method, I mean it is a simple way to calculate how an object heats or cools over time by assuming its internal temperature as completely uniform. Let us have a quick summary. Reynolds number, it is like a tug of war between fluid's momentum and its internal friction. It tells us whether the flow is going to be laminar or turbulent. Prandtl number tells us whether momentum or heat, which one spreads faster. And the third one, Nusselt number, tells us how much convection improves the heat transfer over conduction. So it is convection versus conduction. And then the Grashof number, it shows us whether buoyancy is strong enough to make the fluid move naturally. So whenever you look at Grashof number, you need to remember that it is a number that tells us whether buoyancy is strong enough to make the fluid move naturally. So the lighter fluid moves upward and heavier fluid moves, denser fluid moves downward. And then coming on to Biot number, it tells us whether the inside of a solid stays at nearly the same temperature or not. Thanks for watching.